Okay, guys, example number 3, it says find the perimeter of the figure. And when we're working with perimeter, remember it's just adding all the sides, right? So what I can say is, I can say 3a plus 6 over 4 plus 2a minus 1 over 6 plus 3a plus 6 over 4 plus 2a minus 1 over 6. Now guys, when I have things like this, I really like to use that formula that we learned for perimeter back early in the 6th grade, right? The 2L plus 2W thing. We multiply the length. Because I've got two of these. I've got two of these, right? So I can put them together and just say, okay, 2 times 3a plus 6 over 4 plus 2 times 2a minus 1 over 6 is equal to the perimeter. You agree with that? Okay. And then watch what happens, guys. When I multiply, this 2 cancels with that 4 and it just becomes a 2 down there. Are we all right so far? Does that make sense? What you got, Devin?
I don't know if we should factor yet.
Not yet. Not yet. I'm going to simplify these fractions and then we'll do some factoring. All right. The 2 cancels here with the 6 and that becomes a 3. So now my new formula says 3a plus 6 over 2 plus 2a minus 1 over 3 equals perimeter. Now I still don't have a common denominator, do I? There's no way that I can put these things together because I don't have a common denominator yet, and I'm going to have to do that. Okay guys, the things that just before I pause it here, now what we've got to do is get a common denominator, all right? And I see that I've got a 2 and a 3 down here. But I know that the common denominator is going to be 6 just by looking at those constants, so that's pretty easy, right? But what did I multiply, Austin? What did I multiply this 2 by to get that 6? 3? So I need to multiply the numerator by 3. Okay? In the second fraction, Kyle, what did I multiply the denominator by? 2. So I multiply the numerator by 2. 2a minus 1. Okay? Now, let's go ahead and we can distribute in now, or we can do it after we put them together. I'm just going to do it right now. So I'm going to get 9a plus 18 over 6 plus 4a minus 2 over 6. Oh, do I want to cancel right now, Will? I mean, do I want to factor out and cancel? No, that would be counterproductive. I'm trying to get the same denominator, right? If I canceled, I wouldn't have the same denominator. Okay, so now we need to put these things into one fraction, all over 6. 9a plus 18 plus 4a minus 2, all over 6. Now I'm going to combine the like terms. I get 9a plus 4a, that's 13a. And then 18 and minus 2, that's going to give me 16, all over 6. Now, before I'm done, I've got to check to see if there's anything I can cancel. I never give fractions unless they're reduced for my answer, right? So I need to reduce this if I can. Is there anything I can pull out of the numerator, Troy?
No. Oh, no.
13a plus 16? Is there anything that goes into all of both of those terms?
2.
No, there is not. 2 doesn't go into 13. It's an odd number, okay? And it's not a difference of 2 squares up there, so there's no factoring that I can do. There's nothing that I can cancel out. So this is my answer. This is the representation of the perimeter of that rectangle. All right. Miles, quick question.
I did the long way.
Yep.
So I had everything there.
Yep.
I got 26a plus 32.
Okay.
Could you just put like the 2 in front of it and still like would that answer work?
No, you need to factor all that stuff out and cancel.
Okay.
You've got to cancel.
Okay.
What was the answer that you got?
I got 26.
26a plus 32 over 12.
It's basically the same. It's the same times 2.
It's like giving this as your answer. Am I gonna take off for that? Yeah, definitely. Probably like a quarter. I mean, I'm not going to take off all of it, but you have to say, oh wait, 2 goes into both of those. 13a plus 16 all over 12. Oh look, the 2 and the 12 cancel. Okay, that's my answer. Because I got to reduce